This is not just a ship graveyard, it is a birthplace. In a few months, a vessel that should not exist will emerge from these dead bones and set sail. A Frankenstein's monster of a ship stitched together from the corpses of its brethren by desperate men. We will dissect 3 ingenious engineering tricks and 1 brutal psychological law that made this possible. And this is not fiction. In 1741, the survivors of the British ship HMS Wager, wrecked off the coast of Chile, did exactly this. They built a boat from the wreckage and sailed it for 3,000 miles. What you're about to see is an autopsy of their impossible feat. There is no food, almost no fresh water, and every tide carries precious wreckage out into the ocean. This is not an adventure. It is a race against death. Time is their main enemy. The ocean is their jailer. Without vitamin C, the symptoms of scurvy, bleeding gums, and loosening teeth will appear within a month. But psychology kills even faster, the phenomenon of psychogenic death, when a person simply loses the will to live. Their bodies and minds were ticking time bombs. Their task was broken down into 3 impossible challenges. First, to build a ship without a single whole timber. Second, to make it waterproof using debris from the beach. And third, the most difficult of all, to make a band of ruffians work together when one wrong move meant death for everyone. Building a simple 18th century sloop required over 10,000 iron nails and bolts. They had 0. Their task was akin to building a skyscraper with their bare hands. Let's find out how they solved this impossible problem. Their first wall was not made of stone, it was made of wood. They were working with Virginia oak, a material so dense that cannonballs would bounce off it like armor. Trying to split it with a rock was like trying to cut a diamond with a fingernail. At this point, most would have given up, but they performed their first act of engineering genius. They built a forge, a primitive furnace of stones and clay. For fuel, they used driftwood and charcoal from burnt planks. The bellows were stitched together from remnants of sailcloth and leather from their own boots. In this hellish flame, they melted down weapons, cannonballs, and anchor chains. To forge iron, a temperature of over 2,000 degrees Fahrenheit is required. Their furnace was not just a bonfire, it was the industrial heart of their new civilization, turning symbols of war into tools of creation. A broken saber became a crude saw, iron shackles became a chisel, chain links became the first nails. But there was a cruel catch. These tools were made of cast iron, not steel. They were as brittle as glass. One wrong move, and your only axe would shatter into pieces. They were fighting not just the wood, but the imperfection of their own creations. Put yourself in their shoes. You have a piece of red-hot metal and a rock for a hammer. What tool do you forge first to maximize your chances? An axe, a saw, or a hammer? This isn't just a choice, it's the builder's trilemma. The axe is a bet on speed. Build something, anything, before you starve. The saw is a bet on quality. Build something that won't sink. The hammer is the choice of an optimist, one who believes they can join the pieces without a perfect fit. Your answer defines your risk profile, and everything depended on this choice. But their real problem wasn't the tools, it was the materials. Before them lay the remains of a dozen different vessels, a Spanish galleon, a British frigate, a merchant schooner. Different types of wood, different curvatures of frames, different thicknesses of planks. Assembling a ship from this was like sewing a person together from the parts of different animals. The problem runs deeper than it seems. English oak and Spanish cedar swell differently in water. Combine them in one hull, and upon contact with the sea, some planks will begin to press on others with the force of a hydraulic press, tearing the ship apart from the inside. But they found a solution. There was no paper. The blueprint was drawn directly on the sand. The largest and most intact piece of keel they could find was used as the foundation. It became the spine of the future monster. All other parts were fitted to it, not the other way around. This keel became their constitution. Every piece of wood, no matter its origin, had to obey its law. In essence, they were doing what was done in shipyards, where a full-scale drawing was laid out on the workshop floor. Except their workshop was the beach, and their drawing could be washed away by the next tide. From the perspective of any shipyard carpenter, what they were doing was heresy. They were violating all laws of symmetry and balance. Any master would have said their vessel was doomed to hogging or sagging, a structural failure where the bow and stern droop or arch upwards. Their ship was not a vessel, it was a programmed catastrophe. The plan was insane, but it was a plan. Now came the hardest part, connecting these organs into a single skeleton that could withstand the ocean's fury. And for this, they needed a technique not written about in textbooks. They needed a forgotten technology, born not in royal shipyards, but in the desperation of castaways, the art of stitching wood together. None of the keels they found were long enough. They had to be joined. But how do you connect two giant timbers so they can withstand the impact of waves? The keel of a small vessel endures dynamic loads of tens of tons. That's the weight of several elephants dropping on it, again and again. Any joint in it is the Achilles heel of the entire project. One miscalculation, and the ship would simply break in half on the first big wave. They used an ancient Viking technique, the scarf joint. Complex interlocking profiles are carved into the ends of two beams, allowing them to fit together. Imagine clasping the fingers of two hands, not just pressing the palms together. This joint distributes the load along the entire length of the connection instead of concentrating it at one point. But to carve it with a homemade chisel made of cast iron is a work of genius. Even a perfect joint needs to be fastened. Nails and bolts were critically scarce, so they turned to a technology that seems like a step backward, but was in fact a leap forward. They used tree nails. These are strong wooden pegs made from the hardest woods they could find. They are driven into drilled holes, locking the timbers together permanently. This wasn't just a substitute for iron. In some ways, it was better. An iron bolt rusts and poisons the wood around it, but a wooden tree nail is a living bolt. In seawater, it swells, jamming itself permanently in place. Over time, it becomes one with the hull. The ship literally heals and strengthens itself. Assembling the keel this way was a 7 out of 10 on the scale of engineering madness. Using tree nails instead of iron was a 9 out of 10. But what they were about to do with the planking was pure 10-point insanity. The skeleton was ready. Now it needed flesh that wouldn't leak, and for that they had to resort to a disgusting, foul-smelling but brilliant biological hack. The planking was a nightmare. Boards of different thicknesses and curvatures left gaps between them wide enough to fit a finger through. Any one of them was a death sentence in the ocean. The physics here is unforgiving. At a depth of just 3 feet, the water pressure is about 1.5 pounds per square inch. This means every coin-sized gap is constantly being pushed by a force capable of punching through it like a dull nail. They needed to create armor out of trash. The standard method was caulking with oakum and sealing with tar. They had neither. Instead of oakum, they spent hours unraveling old rotten ropes into fibers. Instead of tar, they cooked a vile concoction. In cauldrons, they boiled sea lion fat mixed with the meager resin they could scrape from the few surviving trees. This process is called paying. It's where the saying, "the devil to pay," originated, which meant sealing the longest and most difficult seam on a ship. For them, the entire ship was the devil. It was a 3-stage defense system. First, every gap was tightly packed with fibers, like grout between tiles. Second, the entire underwater part of the hull was coated with a layer of hot, stinking grease mixture that acted as a waterproof membrane. But that wasn't all. Third, on top of the sticky grease, they nailed pieces of leather from their boots and remnants of sailcloth, creating an outer layer of armor against scrapes. In essence, they created the world's first composite material from waste. The ship was strong, it was watertight, but it was nothing more than a floating box, blind, mute, and immobile. Their creation was a floating corpse. It had a skeleton and skin, but no nervous system. To give it life, they had to perform a complex neurosurgical operation, implanting a rudder, a mast, and sails that would become its brain and muscles. A mast is not just a pole, it is the balance point of the entire system. An error in its placement on an asymmetrical vessel, and it is doomed. Shipbuilders calculate two invisible forces, the center of effort, where the wind pushes the ship, and the center of lateral resistance, where the water resists it. The survivors did this by eye. It's like a tightrope walker finding their balance on a sagging rope. A shift of a few inches, and the ship is doomed to constantly list to one side, or worse, capsize instantly. Next came the muscles, the sails. They were stitched together from dozens of torn, rotten pieces. To pierce the thick, salt-stiffened canvas, they needed a sailmaker's palm, a special leather glove with a metal thimble. They had to make that too. Their sail was a patchwork quilt of ghosts, each piece from a different dead ship, stitched together with scars into a single whole. But the most difficult part was the rudder, the brain of the entire operation. It was carved from a massive piece of oak, possibly the stem post of another vessel. The entire force that turns the ship is concentrated on its hinges, the pintles and gudgeons. If they broke, the rudder, weighing hundreds of pounds, would become an uncontrollable battering ram, punching a hole in their own ship from behind. It was the most dangerous component. Imagine you have only one whole piece of sailcloth. You can make one large but weak sail for speed, or you can cut it into several small but strong ones for maneuverability. One large sail is an all-in bet, maximum speed to escape. Several small ones are a tactician's choice, less speed but more control. Your choice is your survival style, a sprint or a maneuver. But all this iron and wood was nothing compared to the most fragile part of their machine, man. Their main enemy was not the ocean, but a virus that infects any group in despair. Psychology calls it social loafing, the tendency to exert less effort when you are part of a crowd. The captain had to become a surgeon, cutting this cancerous tumor from the collective body of the crew before it killed them all. Typical pirate codes, like that of Bartholomew Roberts, were surprisingly democratic, but here they created an anti-code. It was not a charter of liberties, but a flowchart for survival. Rations were distributed not equally, but based on contribution. The smiths and carpenters, the key specialists, received more. It was unfair, but it was effective. You are useful, you eat. You are a hindrance, you are eliminated. Justice had become an unaffordable luxury. At the center of this system stood the captain. He became Thomas Hobbes's Leviathan, the absolute power necessary to prevent a war of all against all. A single dissenter could be publicly flogged or even killed as a warning to others. This was tyranny, but a tyranny with a single purpose, to save everyone. He was not a leader. He was the group's immune system. Any cell that threatened the organism was ruthlessly destroyed. This was not cruelty for the sake of power, but a biological necessity. The moment comes when all this theory must meet reality. The launch is the final boss. Dozens of tons of dead wood must be moved on log rollers to the ocean. One wrong move, and the ship breaks its back on the shore, never touching the water. The ship slides into the water. A tense silence. It rocks, it steadies, and it floats. A roar of jubilation shatters the air. This is more than a triumph. It is the resurrection of hope. This was not a miracle. It was a protocol. The Frankenstein Protocol, an instruction manual for surviving hell. First, inventory the chaos. Assess everything you have, even the trash. Second, create tools. Don't wait for help. Forge it from what's at your feet. Third, use injustice as a weapon. In a crisis, equality kills. Disproportionately reward key skills to incentivize the most critical work. And fourth, the good enough principle. Don't strive for perfection. Strive for what works. We have witnessed a marvel of engineering and ruthless management. So what was the key to their salvation? The brilliant engineering that allowed them to build the ship? Or the brutal leadership that kept the crew from falling apart? Write just one word in the comments: engineering or leadership. What matters more when you're at rock bottom? A brilliant mind that can build an escape machine, or an iron will that can force people to push that machine even if they hate you for it? Your choice says a lot about you.